Well, good morning, everybody. My name is Scott Fowler. I'm the product manager of Tecplot 360 here at Tecplot. I'm joined today with Wen Long, PhD. He's our senior technical product manager. Wen Long joined us here at Tecplot from Pacific Northwest National Labs, and previous to that, he was a modeler at University of Maryland. And he and I have spent the last year trying to understand the needs of the geoscience community, in particular those doing ocean modeling. Our webinar today is going to be an overview of Tecplot 360 and how it can be used to visualize ocean models. In that year that Wen and I were doing our research on visualization of ocean models, we found that nearly everybody uses a script-based workflow. And this has some advantages, but some inherent disadvantages. And those disadvantages being it can take a long time to write scripts, it can take a long time to get the plot looking just the way you want it for presentation purposes. And it can take a long time to learn APIs to develop your visualizations and do your analysis. So what we're going to present today is who Tecplot is as a company and the products that we offer, and then we're going to give you a live demo loading in some FVCOM data. The data that we're going to be using today was given to us by Pacific Northwest National Labs in Seattle, Washington. Tecplot Inc. is just across the water from them in Bellevue, Washington. And these results are from their Salish Sea model. You can see a link at the bottom of this slide for where you can learn more about that Salish Sea model. Okay, well, a couple of quick housekeeping items before we really get into this webinar. You can always ask a question via the question panel. We are going to take questions and answers at the end of the presentation, so if you do ask a question, we may not get to it immediately. This webinar will be recorded and will be presented on the Tecplot website a couple days after the webinar. All right, so let's start with who is Tecplot? So Tecplot is a data visualization and analysis company. We were founded in 1981 by a couple of Boeing engineers, hence a fairly large user base in CFD, particularly external aerodynamics. We are known as the largest CFD post-processor with approximately 47,000 users worldwide, and our users tell us that we are the most complete post-processor out there, given that we have high quality plotting, 2D, XY, as well as the 3D like you see here. And really, in the past few years, we've been focused on the emerging needs of the CFD community. Models are getting larger as CPU power grows. So we're working on techniques to help you save time in your analysis and visualization. So what are the big problems in post-processing these days? Well, data are getting larger. With the number of CPUs, they're increasing, and the speed of the CPUs, your data sizes are growing roughly with Moore's law. And disks are not getting any faster, and disks are really becoming the bottleneck to loading your data. So Tecplot has some very intelligent disk I/O and memory management capabilities to make sure that you can load large data sets, large transient data sets on a constrained machine. Just to give you a frame of reference, the machine that I'm demoing on today is a Microsoft Surface Book with 4 CPUs, 16 gigs of RAM, and I'm able to load some very large data sets on this machine with Tecplot 360. We also develop in the center column here, we develop a product called Tecplot Chorus. Tecplot Chorus is included with Tecplot 360, and it helps you understand ensembles of data. So if you're doing a large number of CFD runs for comparison with one another, Tecplot Chorus may be a good tool for you. We're not going to demonstrate that today, but know that it's there if you are doing multiple CFD runs and need to do comparisons. And then finally, with post-processing, you need to be able to automate, and we've developed a Python API that we released in early 2017, and we've only improved it and made it faster in the time since then. we will demonstrate some of our Python API, which we call PyTecplot today. We also offer some solutions for developers. So if you are a code developer and want to export Tecplot file format from your code, you can use our TechIO library. The TechIO library is completely free. We offer an MPI version if you need to write your data in parallel. We also offer source code if you need to compile it. With so many different versions of MPI available out there, most people do need to compile the source if they're using the MPI version of the library. We have C++ and Fortran bindings available for that. The Tecplot ADK, a lot of the Tecplot user interface is developed using the Tecplot ADK. So you can actually customize the user interface. You can develop custom readers, custom data writers using C++ and Fortran bindings. And feel free to contact us if you're interested in using that and improving and streamlining your workflows. And then, as I mentioned on the previous slide, PyTecplot, our Python API. Python has really become the glue layer for data science and engineering, and we think that this is really an important component moving forward to help automate and allow advanced analysis. Okay, so that's the overview of who Tecplot is, the products that we have. And now we'll just jump right into the demo. So again, what we're going to show today is a demo of how to use Tecplot 360, and this will be a bit of an instructive video as well on how to load FVCOM data and the things that you may need to look for in your data. What I'm going to be showing today, I'm going to show a beta version. We're not quite ready for release yet, so the capabilities that you're going to see today are going to be available in October of this year. I'm going to show a beta version. So some of this work is still in progress, and we're putting the finishing touches on the release. Hope that you're going to really enjoy it. Okay, so let me just jump right into Tecplot 360. I'll go ahead and launch it. And hopefully everybody can see Tecplot 360 on the screen. Here is the general overview of Tecplot 360. So just a quick tour of the user interface. We have the menu system up top, toolbars where you can load and save files. We have our mouse tools for zooming and translating and rotating your data. We have tools here for annotating your plot with text, lines, geometries, etc. On the left side is what we call the plot sidebar. This is where you're going to change a lot of the attributes, the visual attributes of your plot. And on the right side, we have a probe sidebar. So if you do need to learn more about data within a cell, it'll show up here. And then what we call a quick macro panel. So if there are any repetitive actions that you're taking, you can record a Tecplot macro or a Tecplot script and register it with the quick macro panel. So you can just a quick double click to perform the actions that are there. Okay, right here in the middle, we call this big gray area the workspace or the work area. And then right in the middle, your initial view is what we call the welcome screen. The welcome screen stores recent Tecplot layouts that you've opened. We have links to documentation and online resources. One of the really great resources here is called the Quick Reference Guide. So this has this is documentation that lets you know about all the keyboard shortcuts and mouse tools and some customizations that you can do with Tecplot 360. So take a look at that quick reference guide. All right, so let's go ahead and load our data. So I'll go to the File menu, Load Data, and we'll go to my desktop where I have my FVCOM data set. And I have a netcdf file here. This came from FVCOM. You can see I have FVCOM selected right here. If you do have results from other solvers or other file formats, we have about 35 different formats that we can load here. Like I said, with the Tecplot ADK, you can create your own dataset readers. So if you have a custom format, you can extend this list. We have simple text readers. our general text loader, spreadsheet loader, which can load CSVs as well. If you're on Windows, we do have an Excel reader. So you can load some of your measured data as well for comparison. Today we're going to focus on FVCOM. Okay, so the first thing Tecplot tells me is that the aspect ratio of my data has been adjusted, which you'll see as you load it. This data set represents it's in a UTM coordinate system, so and the depth is fairly shallow. So we've expanded the Z dimension of my data set. Now you'll see we don't see anything except this outer bounding box of my data. Tecplot is trying to do as little work as possible when you initially load your data set. We don't want to load data that's unnecessary. So we haven't really loaded anything. We've just loaded some of the metadata about your data set. So let's take a look at what data we have. So a good way to get a view of your data is turn on the contour layer. This is going to activate the outer boundaries of my data set. And let's just click on the snap to orientation, the XY view. So that's going to give me a plan view of my data. And I want to see a more interesting contour variable. So I'll double click on the contour legend and select, let's say, temperature. Okay, and so now I can see my data set. I'll rotate this around. You can see that I do have a full 3D model here, and it is a little bit difficult to see where we are in the world here. So let's bring in a georeferenced image. So I can go to Insert, Georeferenced Image, and this capability is also available right here on the toolbar, so save you a couple of clicks from having to go up to Insert. And we'll select my georeferenced image. Now, Tecplot does support BMP, JPEG, and PNG image formats, and we also will look for the corresponding world file. So a georeferenced image is simply an image file with a paired world file that explains where it should be placed in the scene. These files can be easily created by GIS tools such as ArcGIS or QGIS. And you can then bring them into Tecplot. Now, do note that Tecplot doesn't do any coordinate transformation here, so make sure that your world files are in the same coordinate system as your data. So here I can select either the ping or the world file and hit open, and it'll bring it in. In this case, I'm really interested in just this lower section of my data set, which is why I have a smaller image here. Now, this georeferenced image is actually a 3D object, so it'll rotate around with the scene. So that makes it quite nice if you do want to rotate around. And let's go ahead and animate through time. So we can see that the image is initially placed at 0, and it is drawn on top of the data as the tides go in and out. So we'll just double click on our image, and let's bring this down to -15, and we can animate through again, and now our data is going to be shown above the georeferenced image the entire time. So a nice easy way to bring in the georeferenced images. Okay, so let me give you an explanation quickly of actually what the data looks like that we've loaded in. One of the most important dialogues in Tecplot is the dataset information dialog. So this will give you some info about what we've actually loaded. So here we have what are called zones. Each zone is effectively a block of your data. In this case, each zone represents one time step. You can see that it's a finite element brick. Each zone has a solution time associated with it and a strand number. So the strand number simply says that all of these zones are the same object through time. You can see that this total data set is fairly small, about 3.3 million total elements through all of the time steps. We have X, Y, lat, long, our spatial variables here. We have some vector components. And you can see we have our salinity and temperature. You can see some interesting information about these as well. So like I said, Tecplot tries to do a very good job of, or does a very good job of memory management. One of the things that Tecplot will do is it won't load data until it's demanded by the plot. So in this case, we're showing X, Y, Z variables, and we're showing temperature. So as we go through this list, we can see that the variables that are not required are not loaded, such as latitude has not been loaded, initial density not loaded. So this is a way of Tecplot saving memory as you're loading your data. So you really don't have to be concerned about loading very large data sets. I have a 250 gig data set of Boston Bay, a simulation out in Boston, and I'm able to load it on my machine because of that memory management. Okay, so that's zones and variables. What we have here is this is what we call a frame. You can have multiple frames in Tecplot to show different views of your data, and we'll get more into that later. Each frame can have a name, and you can manage your frames down here in the frame sidebar. Okay, so let's look at contouring. Contouring is a pretty important part of your creating presentation quality plots, and choosing the right color map is quite important. So here we've chosen temperature, and we're showing the Viridis color map. This is a perceptually linear color map. It's good for people who are colorblind and gives a nice even view of your data. It has a fairly linear increase of luminosity across the scale. So these sequential color maps are really important. Now we'll double click on the legend, and a better color map for temperature is actually one developed by Kristen Thing. She's developed the CM Ocean color maps, and she's been nice enough to release those in open source. So we've been able to bring those into Tecplot. So let's choose the CM Ocean thermal color map, which is a nice one for temperature. And we'll do a continuous contouring, so you can see the difference between continuous and banded. This can give a really nice blended view. Now let's say I also want to look at salinity, so I'll set up what we call contour groups. I'll set up another contour group, and I'll have this one point to salinity, and we'll choose again one of the CM Ocean color maps, and we'll choose Haline, which is very similar to the Viridis, but it has some slightly softer tones. We'll also make this a continuous color map. So now if I want to switch between temperature and salinity, I can simply right-click, select my contour item on the toolbar, and I'll select salinity. And now we're looking at the salinity of our data set. And again, I can advance through time here. So at this point, we're only looking at the upper surface of our data. Now what happens if we want to see a lower level of our data? Well, a good way to do that is with isosurfaces. So let's go ahead and set up an isosurface. So I can go isosurface details. Now, quick note here is we have what we call zone layers. So these are going to be the attributes of the actual physical data that you've imported. And then we have derived objects. So these are going to be objects that are going to cut through your data, your model data. So an isosurface being a derived object. So we want to use an isosurface at siglev. So this data set has values ranging from -1 to 0. -1 is going to be the bottom or the bathymetry. 0 is going to be the surface. So let's take a look at the bathymetry, and we'll go ahead and show this. Now we can't quite see it yet because it's being obscured by my zone data. So let's go ahead and turn off the contour and shade of my zone, and my image is getting in the way. So let's go ahead and move this all the way down to the bottom. So we still have it, and now we can see this is being colored by temperature. Let's look at the salinity on this as well. Okay, so this is the bottom or the bathymetry of my data. We can go ahead and look at the XY plan view again, and a nice way to look at what's going on through the depth of my data is just to animate that isosurface. So let's go from -1 to 0. I meant to type in 0 here. And we'll do 50 steps, and then I can simply animate. So you can see that see how my salinity is changing as I go through the depth. Now if we were to look at the side view, we can see how this is going and changing through the layers. Okay, and so this is my isosurface at this particular time step. If I want to see how that isosurface is changing at another time step, I can simply change my time step and then animate through again. All right, another way to look at what's going on in your data set is to use slices. So we can use our slice tool here. I can simply point and click where I want that slice. So this, put in a constant X. Let's say I want to also look at salinity. Again, I can simply right click and select the salinity contour group. Let's say I want to go through the Strait of Juan de Fuca here. And so let's change this to a Y slice. So I can, with the slice tool active, I can simply press the Y key on the keyboard and that will change to the Y dimension. If I want another slice, I can add slice group 2. Let's go back to X and we'll show this. Again, we'll right click, change that to salinity. So now I have a couple of slices in here. Well, the coastlines are never straight, right? So really what we want to do here is we want to do a curved slice or a transect. And Tecplot doesn't have that capability built in. So this is where the Python language comes in. So let's go ahead and we'll turn off the slice and the isosurface, and we'll come back to my full volume data set. Let's go back into the XY plan view. So let's take a look at a curved slice that goes down through the Puget Sound here. So we've developed a Python script to use a couple of tools in Tecplot 360 to help out with this. So we'll use the geometry tool, and we'll start here at the opening of the Strait of Juan de Fuca, and we'll just try to go mid-channel down through Puget Sound here. I can just kind of click, and I can adjust these points at the end if I don't quite get through mid-channel, and we'll come down in here to, I believe that's Tacoma, Washington down there. So we'll zoom in, and let's just adjust a couple of these points. So I have the adjuster tool here. I'll just move this guy a little, maybe move this one around, and let's move this one down just a little bit. All right, so now I'm happy with where this path is. I'll just do Control F to do a view fit. And now what I'm going to do is I'm going to extract these points to a new Tecplot zone. So let's go into the dataset information dialog and show you what we've done here. So by doing that extract, I now have a new zone that we've created. It's I-ordered, so that means it's just an array of data. And a Python script that I'm going to execute is going to use the XY locations to define the path of the transect. And one of the important things with this script is to ensure that you've captured your grid correctly. So let's just take a look at the grid. I'm going to turn on the scatter layer, and we'll take a look at how many points we have along that line. So let's turn off scatter for my main zone, and we'll just look at scatter for my extracted points. So you can see each one of these points, or this zone, the XY locations, are capturing the grid correctly. We have pretty good density here. We're not jumping over cells. In a couple of places we have a couple of points within a cell, and that's fine. Okay, I'm done with that geometry that I created. I'm done with, so we can go ahead and delete that. And now I'm going to execute my Python script. So we have a scripting menu here. There are a number of ways that you can interact with Tecplot with scripts. We have the Tecplot macro language, which is a language that we developed probably 20 or 25 years ago, but we've recently introduced Python. Python is much more powerful. It gives you the ability to deal with arrays and string manipulation, and actually allows you to extract data out of Tecplot and deal with it. So in order for our Python scripts to run outside of Tecplot and communicate with Tecplot, we need to allow PyTecplot connections. Our Python language actually communicates over sockets. And then I'll come here to a command prompt, and I'll just execute my vertical transect script. And so what this is going to do, first it's going to connect with Tecplot 360, and then for each time step, it's going to create a new set of points which represents my transect, and then it's interpolating all the variable values from the volume data set onto that new point. And then it's going to round out by actually creating a plot of the new transect zone. Okay, so there you go. It took about 22 seconds to do that. We have, again, we have about 3 million total points in this data set, 24 time steps, and here we have our transect showing salinity along that path. Okay. And these two frames are now linked together. So if I animate one, both of them animate. So we can see both of these animate. It's a little hard to see the animation in this upper plot. Let's turn off the mesh and let me show you what that transect actually looks like up in this upper mesh. So we'll again go into the zone style dialog, and this created a new zone, actually a new set of zones, one zone per time step, that are called transect. So we'll turn that on, and we'll turn off our extracted points. And for this, the transect is inside, so how do we see inside there? Well, let's turn off the contour layer, and we'll turn on translucency. Let's make it 70% translucent. And so now I can see the path of that transect. It shows our first contour group is the coloring. So let's, in the zone style dialog, we can say, well, we want this to be colored by salinity. And let's also turn off the mesh. Okay, so now we can see what that transect looks like in our data set. And again, animate through time. One of the other things that people have asked us for is once they've computed a transect, how do you compute a time average? Now, again, this is something that is not directly built into Tecplot 360, but Tecplot 360 does have the capability through the running of equations. So I'm going to run another Python script here to compute the time average. And so what this script does is it asks, well, which strand do you want to average? Remember, we looked at the dataset information dialog earlier, and we pointed out the strand index. So we want to do the time average of my transect. So let's go into the dataset information dialog and find out what strand number that is. All of our transect zones have the same strand number. That's strand number 2. So we'll come back into the command prompt, and we'll just type 2. Now what this is going to do is it's going to create one new zone and compute the average of all of the other zones. So you can see, for instance, temperature and distance used the Tecplot equation syntax, which we'll go into in a minute, and did the summation of all of my transect zones divided by 24, and we now have a new zone called time average, which has the same grid topology as our transect zone. So you see I of 200, a Jmax of 11. This is the same grid topology, and now all of the variable values here represent the average of the transects. So now we want to view that data. So let's, we like this view, so let's just copy this frame. I'm doing a Control-C and then Control-V, and then we'll move our copied frame up. And here I want to have this be my time average. So let's make sure to put an animation here, or annotation. so we know what we're looking at, time average. And down here, we're going to be looking at the transect at a particular solution time. So here we can use Tecplot has what we call dynamic text. So this is a keyword that will show us the time step. All right, so now let's go ahead and animate through here. You see that this is not our time average yet, so we'll go into select this frame, go into zone style, and we'll select time average, and we want this to be colored by salinity. Okay, so now we have a transient frame and a time average frame, and we can again animate through time. You can see that this is now static and representing my time average. Okay, well, let's say what happens if we want to look at another quantity that we don't actually have in the data set. For instance, I have my vector components, u, v, and w, but what I really want to do is I want to look at the velocity magnitude. Well, we can do that quite easily in Tecplot. One way to do it is through the Analyze menu, calculate variables. This has a large number of formulas that you can execute, one being velocity magnitude, so quite easy through here. But let me calculate velocity magnitude by hand to give you a description of the equation syntax. So we go into Data Alter, Specify Equations. One of the key things to know here is the use of curly braces. So curly braces are going to represent variable names. So we're going to do the square root of the u variable squared plus v squared plus ww squared. All right, and that's all there is to it to compute a new variable. Curly braces being the big thing you need to know here. We have a lot of built-in functions, square roots, cosines, etc., and those are all available in the Help menu. So here we can just hit Compute, and now I've computed velocity magnitude for each one of these, each zone. So now let's contour by that. So I'll just double-click on the contour legend, and that's a nice quick way to come up to the contour dialog, and we'll select velocity magnitude, and we'll do the same thing down here. And now I can go ahead and animate that through time and see how my velocity magnitude is changing through my data set over time. Okay, so we've talked about annotations, we've talked about calculating new variables. Now let's talk about how to actually get the data out to your colleagues, and so they can see your results. So Tecplot does have a number of ways of exporting images. We have through the export dialog, we can export static images such as PNG, JPEG. We also have vector formats like EPS, PostScript, WMF. So if you're publishing to a paper, those are some very nice formats to use. But in this case, we have transient data, so we want to create a movie. And so let's reorganize our frames here a bit to take advantage of our 3D data as well. So I'll bring this frame over. Oh. And down. Let's go back to this XY plan view, and we'll hide the contour legend, hide this guy. We can zoom in on our data. Let's make sure that we're showing our transect. And let's say we like this view. Okay, and now we want to export this to a movie format, which we can do here through the details dialog. Okay, so time animation details, we want to export to a movie, so we'll just click on this film strip icon. and let's go to an MP4. And the critical thing here is that we need to select the proper region. So the current frame will export just this one frame with the bold border around it, but we want to export all the frames. We'll specify a width. Let's go 1024. Let's specify an anti-aliasing of 3. Anti-aliasing is nice. It makes your text look nice and smooth on output. And let's specify our animation speed. So we only have 24 frames here. So let's go 6 frames per second. So we'll end up with about a 4-second video. We'll hit OK, and let's put this right in our folder here. Just call it movie. And we'll hit save. So this will take just a minute to render, and then we'll take a look at what that movie looks like. So at each one of these time steps, it's loading the data, it's rendering to an image, and then finally it compiles all those images into an MP4 file. Looks like it's done, and we'll just double click on the movie here, and there's our output. So really nice way to create images for your for sharing and movies to share with your colleagues. Okay, so that's what we had for the live demo. So let's jump back into the PowerPoint presentation. So let's summarize what we saw today. We saw really a nice way to load your data and interact with your data without having to write too many scripts. Now we did show some the use of some Python, which may be required for doing advanced analysis, for doing really advanced movie creation. But for the most part, Tecplot 360 really allows a way to load your data and interact with it, make all those fine-tune adjustments for your final plots in an interactive manner rather than having to rerun scripts to get text in the right location or a contour legend with the right values on it. You can automate your analysis with PyTecplot. One of the great things about buying Tecplot 360 is you get access to our technical support staff. We have a great staff here that can help you write some of these scripts. So rather than you having to go into Google and try to find out how to write a script to create a curved transect, you can just call up our tech support staff and they can help you out. You can load really large data sets. Like I said before, Tecplot 360 has been developed with large data sets in mind. We've added parallelism to the product, so it'll take advantage of all your CPUs when you're doing things like creating slices or isosurfaces or calculating new variables. You can get recognized. Your papers are going to look great with the high quality raster and vector export formats that we have. I know that a lot of people doing ocean research are in academia, and you have to you use LaTeX quite a bit. So we do actually have support for LaTeX fonts within Tecplot 360, and many universities already have Tecplot 360. So if you don't know if you have 360 access to it, you can always contact us to see if you already have access. Now, what you saw today, we've sent out to a number of people already to do some beta testing for us, and these are some of my favorite quotes from people that we've worked with. I really love the one from Blake Clark here saying, "This is way better than what I was using before. It's really easy to navigate." So, he came from a pure scripting background, and he said that he was really able to accelerate his work and get his work done faster using the point-and-click interface. Being able to record Python scripts directly from the Tecplot 360 user interface gave him a great head start in using our Python API as well. And then just a kudos to our tech support guys. This bottom quote, "I've been in the IT business for 25 years and you provided the best support of any vendor I've worked with to date." That one just points out that we do really have a great tech support staff, and we're always eager to help you guys out. Thanks for watching. We appreciate your attendance, and the attention that you gave us today. This webinar will be posted on our website, tecplot.com/webinars. To learn more about Tecplot 360, you see the link there, and then as I just mentioned, you can always download Tecplot and try it for free. We have a hassle-free 5-day trial, so you can download it, and your trial starts from the first time that you start Tecplot. So if you download it and get distracted, not to worry. You can install it and run it, and the 5-day trial will start when you start running it. During those 5 days, you have access to our tech support staff, and we can help you load your data and create some of these plots, even help develop some Python scripts to do some advanced analysis if necessary. So please take advantage of that and compare it to your existing workflow. I think you'll be really excited and happy. Thank you very much. Again, we appreciate your time.